All right, hello Algebra 1 Honors. How you doing? Sorry I can't be here today, but I would like to explore graphing exponential functions in this video for you, and I think you'll kind of enjoy it maybe. So this should look familiar from yesterday. This is the exponential growth function formula. And just a quick review, B is your growth factor. And A is your, typically it's your initial amount when you're talking about a word problem or an application, but it's also your y-intercept when you're graphing. And that'll be helpful to realize. Well, there's something interesting about exponential growth functions, or actually exponential functions in general. They have this idea here. They have this component of them called an asymptote. And it's kind of fun to say, asymptote. The P is kind of silent, I guess. But an asymptote is a line that a graph approaches more and more closely but never touches. So an asymptote is a line that a graph approaches more and more closely, but never touches. The space between them gets consistently closer, but you never get there. It's kind of an interesting idea. And so it turns out that exponential graphs have asymptotes. You don't actually graph the asymptote, but it exists nonetheless. So what we're going to do is we're going to use a table of values to graph y equals 2 to the x. This is kind of like a parent graph of exponential functions. It's one of the most basic ones you could do. And to graph this parent graph, and when we graph anything in general for the first time, we're just going to make a table of values. And typically we would do -2, -1, 0, 1, and 2. It's a good idea to use some negatives. Sometimes weird things happen at 0, and positives are a good idea. But yeah, so just let's plug these in and figure it out. So if x is -2, that would be 2 to the -2. I'm actually going to do these by hand, but you could do a calculator if you want as well. I kind of like doing them by hand because it reviews our properties of exponents. Negative exponent's going to flip it over, then we square it, and you're going to get 1/4. 2 to the -1 flips it over, 1/2. 2 to the 0, what's anything to the 0 power? You got it. And 2 to the first is 2, and 2 squared is 4. Okay, so now plot these points and take a look and see what's going on here. So -2 up 1/4, -1 up 1/2, 0, 1, 1, 2, 2, 4. Okay. Now, you see how this is not a line, is it? It's not straight. It's got this bend to it. And exponential functions, they all have this bend to it. Sometimes it's more sharp. Sometimes it's less sharp. Sometimes it's more subtle. But what you would find out is that as you used bigger and bigger negatives, the numbers will get smaller and smaller because it's flipping the 2 over. They'll become smaller and smaller and smaller and smaller and smaller, but they'll never be 0, and they'll never be negative. So what happens is it'll get smaller, 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 and it will look like it's touching the x-axis in this case, but it's not. It's one of those things where if you are on Desmos and you graphed it, you zoomed way in, you would say, oh, there's still a gap. There's still a gap. And no matter how close it looks, no matter how much on top of that line it looks, it's never going to get there. On the other side, what's going to happen is this will get steeper. It'll get steeper, but it's going to continue going to the right. For example, we could put like 3 in, so 2 to the 3rd power is 8. So let's get another point on here. Why not? But it's going to get steeper and steeper as you go to the right. Steeper, steeper. But I want you to make this clear. It's going to continue going to the right. It's just the numbers are going to be gigantic. They're going to be huge. But you can continue, this graph continues going to the right forever, continues going to the left forever. All right, so the asymptote is going to be really important when we graph some of these that are more complicated, that aren't just the parent graph. So I like to draw in the asymptote. And in this case, our asymptote was y equals 0. And which is actually the x-axis. Okay, now it does say to identify domain and range, and we haven't done that for a little bit, so let's talk about that. Because I made such a big deal about saying it goes to the left forever, to the right forever, that means our domain would be all real numbers, everything. But our range is our y values, and we just discussed this, that it's going to get closer and closer. The y values are going to get closer and closer to 0, but they're never going to get there. They're never going to get there. And then on the flip side, it's going to go up forever. So our range for this would be y values that are greater than 0. Not equal to, just greater than. All right, now what I'd like to do is I would like to manipulate the parent graph a little bit and see how it changes the graph. And I would encourage you to, on your own, go to Desmos and try this out. I'm not going to switch over to Desmos because I got my camera rigged up here. But I'll just show you what's going on. So I'm going to graph the y equals 2 to the x. That's our parent graph. I'm going to graph that. Put this back on there. Oh, well, let's see. Actually, I'm sorry. It was right there, wasn't it? And half, and then down, and then 2, and then, okay. So here's our parent graph that I graphed earlier, or just above. But then what happens is, and I would just encourage you to use Desmos to just make it a little quicker. When you put that 3 out front, it changes things. Instead of having a y-intercept of 1, it has a y-intercept of 3. And what it does as well is it still goes towards 0 on the left, but as you cut through here, it's gonna get a little steeper, like so. It's gonna have bigger values sooner. So that was y equals 3 times 2 to the x. Now if you plug in y equals negative 3 times 2 to the x, you're going to find out that, well, the y-intercept is now down here. It's at negative 3, and all the values from 3 times 2 to the x have been flipped over, like so. And I encourage you, just plug these into Desmos, explore a little bit, and you'll see those relationships. Now it says compare the graphs of the graphs and then that we just did. And so let's describe what happened here. And we've actually talked about translations and transformations before. And here they are again. So the number out front, is it's the y-intercept, but it also causes a vertical stretch or shrink of the parent graph. So when it was a 3 out front, 3 is bigger than 1, and so what happens is you're multiplying values by 3, you're stretching them out vertically. If your number out front is a fraction, then it's going to be a vertical shrink. You're going to be shrinking those y values down. And then what happened when we put a negative out front? Well, when negative, the graph is flipped, we say, but we're going to be mathematical about it. When negative, the graph is reflected across the x-axis. When negative, the graph is reflected across the x-axis. And we saw this when we graphed, I know where we saw it. When we graphed absolute value functions, you could see all these different changes, and it was pretty cool. And so those same exact transformations that we saw with absolute value graphs, we're going to be seeing with exponential graphs as well. So it's kind of cool. All right, let's flip this over. So what happens is yeah, you can change the number out front, but you can also manipulate it in other ways. And so what happens is, and this again is the same as when we did absolute value graphs, the number out front, that's what we've already talked about. We talked about how that's a stretch, a shrink, or a vertical reflection. But now we're manipulating it in other ways. And I encourage you can use Desmos to explore a little bit, but when you add a number on the back end of these things, it makes it shift. It's going to be a vertical shift. And it's going to be up or down, depending on if you're adding or subtracting. And then this minus h right there, that is going to be a horizontal shift. Left or right, depending on its sign. But here's the thing you might want to remember. The reason they make it minus like that is because it's going to be the opposite of what you would intuitively think. It's going to be the opposite. So if it's x plus 3, and I encourage you to try this on Desmos. If you do x plus 3 as your exponent, it's going to actually move the graph left 3. If you go minus 3, it'll move it right 3. So it's the opposite of what you would think. Okay, so on these graphs right here, they are transformed, they're manipulated, and what we're going to do is, let's not worry about domain and range just for time's sake. But what we're going to do is we're going to do a two-step process. We are going to graph the shifted graph first. We're going to graph a non-shifted, non-translated graph first. So this is the shift left and right. This is the shift up and down. We're going to ignore those, and we're going to use a table of values, and we're just going to graph 3 times 2 to the x. And so you make your table of values, -2, -1, 0, 1, 2. You plug those in for x. You can do it by hand or you can do it with your calculator. Doesn't matter to me at this point. I think you'll find it's actually quicker if you do it by hand. This flips it over, it's 1/4, and then times 3 is 3/4. And flips it over, it'd be 3/2. I don't like graphing 3/2. I think it's easier to graph 1.5 would be easier to graph. 2 to the 0 power is 1 times 3. 2 to the first is 2 times 3 is 6. And 2 squared is 4 times 3 is 12. So here's how this works. You're going to plot these points. -2, 3/4. -1, 1.5. 0, 3. 1, 6. 2, 12. Way up there, huh? Don't connect them just yet, because this isn't our final graph. This was the non-shifted graph. But what we're going to do now is, for step 2, to get the real graph, is we're going to shift it. We're going to shift each of these points. And our shift is going to be from there and there. It's going to be right 1, down 3. Right 1, down 3. Now, well, guess what else is going to shift right 1 and down 3? This original asymptote is going to shift right 1, which doesn't change it at all. It's still there. But then it's going to move down 3. So go ahead and draw your asymptote, a dashed line, at -3. At y equals -3. Go ahead and do that. Then shift each of your coordinates right 1, down 3. And now, knowing that this is our asymptote, we won't accidentally do our graph too far down. And we can go ahead and connect these bad boys. And what we've just done is graphed a shifted graph, which is kind of cool. All right, let's do one more. Start out by graphing the non-shifted graph first. So our non-shifted graph, we're still going to keep the negative with it, 0.25, but just x. We ignore the shifts. We ignore the +2 and the +3. Ignore those. Make a table. -2, -1, 0, 1, and 2. Plug them in. You like those announcements? All right. And then Grab a calculator if you want. They're decimals, so might as well, I guess. Grab a calculator, punch them in. You're going to get negative 16 if you entered it into your calculator correctly. Negative 4, negative 1, negative 0.25, and negative 0.0625. Pretty small. And you're going to go ahead and plot those. Negative 2, way up there, 16. Oh, it's kind of way up there. I think I actually ignored the tall one last time. Yeah, negative 2, negative 16, way up there. Oh, I'm sorry, down there. I'm getting confused with the announcements. Be negative 2, way down here at 16. But then we also have negative 1, negative 4, 0, negative 1, 1, negative 0.25, and then 2, negative 0.06. So it's pretty tiny. And our asymptote is at the x-axis, y equals 0. But now we're going to, for step 2, to get the shifted graph, we're going to shift. We're going to shift it. And we're going to shift left 2, up 3. Left 2, up 3. Oh, wait, before I do that, what else is going to shift left 2, up 3? You got it. Your asymptote. Left 2, and then it shifts up 3. So let's get that out of the way. Get that asymptote in there. And then we're going to shift each coordinate. Left 2, up 3. Left 2, up 3. Left 2, up 3. Left 2, up 3. And there we have our shifted graph. Like so. All right, I hope this kind of makes sense. I hope you explored with Desmos a little bit. The practice for this is page 310, numbers 21 through 40, all. And I probably owe you some graph paper. All right, thanks so much. Have a good day.